Okay, so we've got all our variables set up for interping for our item, and we're ready to get this actually implemented. So one of the final things that we need to do is make sure that we're setting our be interping variable to false in our finish interping function. So up here in finish interping, we can set be interping equal to false, and that way we won't be interping when the interp timer has finished. Now we created this start item curve function, and this is what gets the interping set into motion. And this is going to be called on the character class. So if we go to shooter character.cpp and we search for the select button pressed function, so let's search for select button pressed. Here we'll see that we cast the trace item to a weapon and call swap weapon. But instead of swapping the weapon right away, we're going to start the item curve instead. So we don't need these two lines anymore. We're just going to take trace hit item, and we're going to call that public function we created called start item curve. And start item curve takes a shooter character pointer, and this is where we can pass in this. And that way, our start item curve will take this pointer to our character. And that way, in item.cpp in start item curve, we can set the character variable equal to this pointer that we're passing in. So that's how we get that reference to the character. Now we're ready to create a function that will do all of the interping and item position updating. So let's go to item.h and create that function. So here in the protected section, we'll create a function that returns void, and we'll call this item interp. Now this will go into the tick function, and it will take a float called delta time because we will be doing some interpolation in this function. Now I'm going to give this a comment, and we're going to say handles item interpolation when in the equip interping state. So we can go ahead and get a body created for this function. And here in item.cpp, we can start fleshing out this function. And the first thing we can do is check to see if be interping is not true. If be interping is not true, we can return from this function immediately. And after that, we can start doing our interping. Now, before we start fleshing this out, we can make sure to call item interp in the tick function. So if we go up to the tick function, here just under the call to super, we can call item interp and pass in delta time. And now we know that this will be called every single frame. And I'm going to give this a comment and say handle item interping when in the equip interping state. So now we know it'll be called every frame. So back here in item interp, now we're ready to actually start handling the item's location here. So the first thing we need to check is to make sure that our character is valid, because we're going to be getting values from the character. We also need to make sure that our item Z curve is set. Remember, that's going to be set on our blueprint. So if that's not set and we try to access it, then we'll crash. So we're going to get a couple of values here. We're going to get the elapsed time that has passed since we started our timer. That's going to be a float. We're going to make it a const float since we're not changing it here in the function. And I'm going to call this elapsed time. Now we can get this using get world timer manager. And from the world timer manager, there's a function called get timer elapsed. And this takes a ftimer handle. So we're going to get our item interp timer and pass that in. Okay, so this is the time that has passed since we started our timer. So we're going to say elapsed time since we started item interp timer. So that is how we get the elapsed time. Now we need to get the value corresponding to this time on our curve. Now, just in case you've forgotten, a curve is sort of like a function. You can use a time to pass into the curve, and the curve will return a value that corresponds to that time on the curve. So we're going to store that curve value in a local float variable, and it's also going to be const. So it'll be a const float, and we'll call this curve value. And we can get the curve value from the item z curve by calling the function get float value. And to get the float value, we simply pass in the elapsed time. So that gives us our curve value. So we'll give this a comment and say get curve value corresponding to elapsed time. Now we're going to alter the item's z component of its location according to this curve value. But let's take a look at our curve value one more time. Here in the editor, in the curves folder we created, we can double click our item z curve, and you'll see that the time value ranges from 0 to 0.7 seconds. So if this value rises and then hovers around 1 for a moment before dropping off, and this 1 value corresponds to when the item is floating just in front of the camera at that camera interp location, then we need to multiply the curve value by some number that will put it exactly in front of the camera during this part here. In other words, here is the item where it starts off. This location's z component is the initial item location when the curve starts. And then the item's z component of its location is going to rise and then hover right about here. This is the elevation of our camera's interp location. So our curve value needs to be multiplied by this distance here. We'll call it delta. We can get this delta using our initial item location at the beginning of the timer and our camera's elevation here. That value is what we need to scale our curve value by. So we can do that by getting our item location. So let's make an f vector called item location, and we'll set that equal to item interp start location. So this comment will say get the item's initial location when the curve started. Now we also need the camera interp location. That's the location just in front of the camera and elevated just a little bit. I'm going to make a const f vector and call this one camera interp location. And I'll initialize this with our characters function get camera interp location. Remember, we made that public function and we knew that we'd have to call that here on the item class. So this comment will say get location in front of the camera. Now I'm going to create another const f vector, and this one I'm going to call item to camera, and this will be initialized with an f vector, and this vector will have 0 for its x and 0 for its y, and for its z we're going to take camera interp location minus item location. This is the vector from the item to the camera, but I only want the z component of that, so I'm going to say dot z here. So item to camera is a vector pointing straight up. Its x and y are 0, and its z is the vector from the item to the camera location, at least to its interp location, the z component only. So basically it's zeroing out the x and y of this vector. And so this is going to be the delta vector. So we're going to say vector from item to camera interp location, x and y are zeroed out, so it's pointing straight up. And finally, I can get the size of this vector. I need a semicolon there, can't forget it. I can get the size of this vector. It's going to be a float. I'm going to make a const float and call this delta z and initialize this with item to camera dot size. And this is going to be a scale factor. I'm going to comment it and say scale factor to multiply with the curve value. Or I'll just say multiply with curve value. So now I can take item location and I can take its Z component and add to it. Remember, this is the initial item location. We're initializing it with item interp start location. So it's the location when the curve first started. And so I'm going to add to this the curve value, but I'm going to multiply it by delta Z. And so what this is doing here is adding curve value to the Z component of the initial location, and then in parentheses scaled by delta Z. So all that's left here is to set actor location, and we're going to use this item location. So we're going to pass in item location, and we're going to say true for sweeping. We want this to be sweeping, but I don't care about the hit result, so I'm going to use null pointer for the hit result. And for the teleport type, I'll use eTeleport type, teleport physics. So now this function is going to update the item's location according to the curve scaled by delta Z. And again, delta Z is the length of the vector pointing straight up from the item's initial location to the camera interp location. That's why we got the vector from the item's initial location to the camera location and then zeroed out its x and y, giving us just the vector from the item initial location to the interp location in the z direction. Then we got the size of that and we called that delta z. So our curve only goes up and hovers around the value of 1. So by scaling that by delta z, it goes up almost to twice delta z and then hovers around delta z for a while, and then it drops down out of view of the camera. So we can compile this now. So here we are in the editor, and the last thing we need to do is go to base weapon BP and set the item z curve. Let's click the drop down and select item z curve. So we're setting it to our item z curve that we created here. Now let's go ahead and click play, and we'll come up to our item and we will hit the E key, and there it goes. It happened pretty quickly, so I'm going to do it again to another item. There it is. So it flies up and it hovers above that elevation of the camera desired location, and then it falls back down, and then we get the swap weapon occurring. Now we don't alter the X or Y components of the location of the item. We're only affecting the Z coordinates. So it's going to stay in the same location, and it's only going to change its Z location according to the curve. So in the next video, we're going to actually change its X and Y location by interpolating it towards the XY coordinates of our camera's interpolation location. So we're going to do that in the next video. So see you soon.